Hi everyone and welcome back to another lab. In today's video, we are going to dive into another crucial topic. We are focusing on verifying and influencing the election process for the designated router and the backup designated router in multi-access network. But first, we will go through the how the OSPF elects the DR and BDR. Then we will go through the lab topology and lab objectives. After that, I'm going to cover the lab tasks and then finally walk you through the lab solution. By the end of this video, you will be able to configure OSPF on a network of routers in a broadcast or multi-access environment, and you will be able to verify the OSPF DR and BDR election using output from certain commands, and you'll be able to adjust OSPF priorities to control which routers is elected as the DR and BDR. Finally, you will be able to re-examine the DR and BDR election process after changing the OSPF priorities. So first things first, let's explain in detail how the OSPF DR and BDR election process works and why it is important in multi-access networks. So the purpose of electing a DR and BDR is to reduce the number of adjacencies and manage OSPF routing updates more efficiently in these types of network, and simplifying the distribution of link state advertisements. Instead of each router forming an adjacency with every other router in the network, routers communicate through the DR, significantly reducing overhead. So in an OSPF broadcast network, routers exchange hello packets to discover neighbors, and these hello packets contain critical information like router priority, router ID, and details about which routers are currently functioning as DR and BDR. The DR and BDR are chosen based on router priority and the router ID during the neighbor discovery process. When OSPF routers start up, they exchange hello packets to discover other OSPF routers on the same network segment. During this exchange, each router advertises its priority value and router ID. If there is no DR or BDR has been elected yet, all routers participate in the election process. The router with the highest priority becomes the DR, and the one with the second highest priority becomes the BDR. If two routers have the same priority, the router with the highest router ID will win the election for the DR role, and the next highest router will become the BDR. If the DR fails, the BDR takes over as the new DR, and another election is held to select a new BDR. This automatic promotion helps prevent disruption in OSPF routing, ensuring that routers can continue to exchange routing information efficiently. If a router's priority is set to 0, it will not participate in the DR or BDR election. It will form an adjacency with the DR and BDR, but will never be considered for election. Also, you need to be aware of that OSPF does not preempt the DR or BDR. Once they are elected, even if a new router with a higher priority joins the network, the DR and BDR remains in their roles until a failure or network topology change triggers a new election. So with that being said, let's move into the lab topology, and as you can see on the screen, we have 4 routers that will be used to connect multiple networks. So if we were to look at the left hand side of the topology, we can see router 1 is connected to a couple of devices, router 2 and switch 1. Switch 1 is connected to PC 1, and that network segment is going to be part of the 192.168.10.0/24. And the network segment between router 1 and router 2 will be 10.0.0.0/30 via serial 0/3/0. And router 2, router 4, and router 3, all of these routers are part of the multi-access network, and all of them are connected to switch 2. So router 3 is connected to switch 3, and switch 3 is connected to PC 3. And this network segment is going to be part of the 192.168.30.0/24. And router 4 is connected to switch 4, and switch 4 is connected to PC 4, and that network segment will be part of the 192.168.40.0/24. We will configure OSPF across all routers, and the OSPF type between router 1 and router 2 will be point-to-point OSPF network type, and between router 2 and router 3 and router 4 will be OSPF broadcast network type. Again, all end devices are pre-configured with the appropriate IPv4 address settings, and they are good to go. So regarding the lab tasks, we will start by configuring all the LAN interfaces across all routers with the appropriate IPv4 address settings. Then we will move to step 2, where we are going to do the same but on the WAN side. And then we will jump into router 2, router 3, and router 4 to configure the interface that is connected to the switch. Then we will move to step number 6, where we are going to enable OSPF v2 across all routers and enable all network to take part of the OSPF process. Next, we will then check which router becomes the DR and which router becomes the BDR. After that, we will go to step 9, where we need to force R3 to become the DR and force R4 to be the BDR. And then finally, we will verify our configuration and then save the configuration, and that will be the end of the lab. Okay, so this is the moment where I ask you to pause the video and try this yourself to test your knowledge and skills. So I have added the lab document in the video description so you can download it and practice at your own pace. I've also included a couple of packet tracer labs for you to download. You will find a pre-lab and a post-lab version. The pre-lab is for those who want to tackle all tasks from the beginning, while the post-lab provides the full lab solution. Okay, so I'm gonna go ahead and tackle the first task, and we need to jump into router 1 CLI, and I'm gonna go to enable mode, and from there I'll go to global config, and then I will start configuring the LAN interfaces. And the router 1 LAN interface is going to be gig ethernet 0/1. I will always set the description first, and I'm gonna say link to switch 1. Let's set the IP address. So I'm going to say 192.168.10.254. And let's set the subnet mask, which is 255.255.255.0. And we would need to enable the interface. Now that we've done that, we would need to configure a loopback interface. So I'm going to say interface loopback 0. Let's set the IP address with 1.1.1.1. 255.255.255.255, which is lat32. And then I'm going to hit end, and let's just verify that quickly. And you can see that we have configured the gig ethernet 0/1 as well as the loopback 0. And both interfaces are in the up state. Next, I'm going to jump into router 3 and do the same thing. So I'll go back to my topology, and then I'll go to router 3 and do the same thing. So I'm going to go to user privilege mode, and from there I'll go to global config. And again, I will configure the LAN interface. So I'm going to say interface gig ethernet 0/1. Let's set the description. So I'm going to say link to switch 3. Let's set the IP address. That's going to be 192.168.30.254/24, which is 255.255.255.0. And we need to enable the interface. So I'm going to say no shutdown. And then after that, we need to configure the loopback 0. And I'm going to say loopback 0 IP address 3.3.3.3, 255.255.255.255. And let's just do some in-flight checks, and you can see this interface is in the up state, and the same applies for the loopback 0 as well. Let's jump into router 4 next. And the LAN interface on router 4, I think, is gig ethernet 0/0 this time. So let's set the description. I'm going to say link to switch 4. And then next, we're going to set the IP address. So it's going to be IP address 192.168.40.254/24. And we're going to say no shutdown. I'm going to exit this, and let's configure a loopback 0. And we're going to set the loopback address with 4.4.4.4, and the subnet mask is /32. Let's just verify that quickly. And you can see that this interface gig ethernet 0/0 is in the up state, and you can see this is the IPv4 address, and the same applies for loopback 0 as well. Next, we need to jump into router 2, and all what we need there initially for this step is to create a loopback 0 interface. So I'll go to my topology and I'll select the router 2 stencil. And from there, I'll go to user privilege and then global config. And then I'm going to say interface loopback 0, IP address 2.2.2.2, then /32. And you can see that the loopback interface has been configured appropriately and accordingly. Next, let's initiate a ping from each PC to the default gateway, just to make sure that the LAN network is working as expected. So I'll go back to my topology and then I'll go to PC1 and then I'll go to desktop and then go to command prompt. And let's try to ping the default gateway 192.168.10.254. And we can see that there is connectivity to the default gateway. Let's go to PC3. On PC3, we can ping the default gateway as well. And then finally PC4. And we have reachability and connectivity. Okay, next let's move into step number 2, where we need to jump back into router 1 and router 2 and configure the WAN interface, which is serial 0/3/0. So I'll go to router 1 and then I'll go to global config and then set the interface ID to serial 0/3/0. I'm going to set the description and I'm going to say link to router 2. I'm going to set the IP address with 10.0.0.1/30, which is 255.255.255.252. And also we'll need to enable the interface and I'm going to exit. Let's jump into router 2 and do the same thing. Gonna set the description first. And next I'm gonna set the IP address. And we'll need to enable the interface. So I'm gonna do some in-flight checks. So you can see that serial 0/3/0 have an IP address of 10.0.0.2 and right now is in the up state. What we can do is we can try to ping the other side of the link. So I'm going to say ping 10.0.0.1 and we have reachability and connectivity to router 1. Next, let's move into step number 3, where we need to configure the interface gig Ethernet 0/0 on router 2. So I'm going to go back to global config and I'm going to set the interface ID to gig Ethernet 0/0. Let's set the description. And I'm going to set the IP address as well, which is going to be 10.10.10.10.10.2. And the subnet mask is going to be /29, which is 255.255.255.248. And I added another octet. And then we would need to enable the interface. So I'm going to say no shutdown. And I'm going to end. And let's just verify our configuration quickly. And you can see that gig Ethernet 0/0 is configured with this IPv4 address. And right now it's in the up state. Now let's move into step 4, where we need to do the same on router 3. I'm going to set the description. Next, I'm going to set the IP address with 10.10.10.3. 0/29. And also we need to enable the interface. I'm going to hit end, and then I'm going to say show IP interface brief. And you can see that we have configured gig Ethernet 0/2 with the 10.10.10.3, and it is in the up state. Next, I'm going to jump into step number 5, where we need to go to router 4 and do the same thing. So I'll go to router 4 and I'm going to go to global config. And I'm going to set the interface ID with interface gig Ethernet 0/1. I will include the description as well. And I'm going to set the IP address with 10.10.10.4/29, which is 255.255.255.248. And also we need to enable the interface. Let's just do some in-flight checks. And you can see that this network or this IP address has been assigned to gig Ethernet 0/1, and that interface is in the up state. Next, we will need to enable OSPF across all routers. So I'm going to start with router 3. So I'll go to router 3 and I'm going to go to the global config. And then from there, I'm going to say router and then OSPF, and then I'm going to include the router ID to 30. And then to enable all networks to participate in the OSPF process, we need to issue this command, network 0.0.0.0, and also we need to include the wildcard, since the wildcard is the opposite of the subnet mask. So we would need to say 255.255.255.255. Basically, this configuration makes all interfaces on the router take part in the OSPF process for the specified area. And then we need to say area 0. Let's just do in-flight checks. So I'm going to say show run pipe section, and then I'm going to include the word router, and you can see that we have configured the OSPF process with this network command. I'm going to do the same thing on router 4. So I'm going to say router OSPF 40, and then I'm going to say network 0.0.0.0, and the wildcard is going to be 255.255.255.255, and it's going to be part of area 0. And let's just do some in-flight checks, and you can see that we have configured the router OSPF 40 with this network command. And as you can see, we have received a log message or syslog message, which indicates that we have formed an adjacency with the neighbor ID of 3.3.3.3, which is router 3. Next, I'm going to jump into the next task where we need to do the same thing on router 2 and router 1. So I'll go to router 2. I'm going to say router OSPF 20, and I'm going to say network 0.0.0.0, and the wildcard is going to be 255.255.255, and the area is going to be 0. And I will jump into router 1 and do the same thing. And as you can see, I just noticed that we have received the syslog message indicating that we have formed an adjacency with neighbor 2.2.2.2, which is router 2. Next, we need to issue the appropriate command to determine the state of the OSPF interfaces. So I'm going to say show IP OSPF interface brief, and this command provides information related to all the interfaces that are participating in the OSPF process. So for instance, this interface is the loopback interface for router 1, which has an IP address of 1.1.1.1/30. The second entry that we see here is the serial 0/3/0. You can see it's the current state is point to point, or it says here point, which indicates it's point to point. And you can see the current IP address is 10.0.0.1/30 and is part of the area 0, and the current process ID is 10 for the OSPF. And then the first entry that you see on the screen is the gig Ethernet 0/1. This is the LAN network. And as you can see, it has the IP address of 192.168.10.254/24. And right now it does say that this is the DR because that's just the default behavior of the OSPF. Now we need to jump back into router 2 and examine the output from the same command. So I'll go to router 2. And I will issue show IP OSPF interface brief. And right now you can see that gig Ethernet 0/0, which is connected to switch 2, is in the DR other, which means it's not the DR and is not the BDR. And again, this interface or this entry is related to the serial 0/3/0, which is the link to router 1. And you can see right now is the current state for that interface is point to point. And finally is the loopback interface, which has an IP address of 2.2.2.2. And all of these interfaces are part of the area 0 and part of the same process ID or OSPF process ID. Let's do the same thing on router 3 and router 4. So I'll go to router 3 and I'm going to say show IP OSPF interface brief. And right now we can see that the first link, which is gig Ethernet 0/1, that is connected to the LAN network and the current state is DR. And the second entry, you can see that gig Ethernet 02, which is connected to switch 2, the current state for it is also DR. So by default, we can see that router 3 is the DR. However, if there is a topology change that happens in the network, this router is not going to be the DR by default. And before I reset the OSPF process, let me just go quickly to router 4 and confirm that router 4 is the BDR. So I'm going to say show IP OSPF interfaces brief. And right now you can see this is the interface that connects to the multi-access network. So gig Ethernet 0/1, and you can see the IP address is 10.10.10.4. And right now you can see it's the BDR router, which means router 4 right now is the BDR for that network. Now, if I were to reset the OSPF process, router 4 will win the election by default. And the reason being is because they all would have the same priority value, which is the default. However, the router ID for router 4 will be the highest. So I'm going to say clear IP OSPF process, and I'm going to say yes. Please do not try this in the production environment because we'll bring all the neighbor down and then we'll bring it back up again. Now that we've done that, I'm going to up arrow multiple times to get to the show IP OSPF interface brief command. And right now you can see that router 4 is the DR. So another command that I would like to share with you is the show IP OSPF interfaces. Okay, so from the output that you see on the screen, you can see that this is the interface ID. You can see the current status is in the up state. You can see the IP address. You can see the area that this interface is part of. And you can see that also this interface is part of the OSPF process ID of 40, and the current router ID is 4.4.4.4, and the network type is broadcast. And if we were to look at the gig Ethernet 01, you will find similar attributes, as you can see on the screen here. And this line indicates that the designated router is 4.4.4.4, which is the local one. And the backup designated router ID is 3.3.3.3. And also it gives you the IP address of the designated router. Now I'm going to jump into step 9, where we need to force router 3 to become the DR and router 4 to be the BDR. So I'm going to go to router 3 first. And I'm going to go to global config, and I'm going to go to interface config level, which is going to be interface gig Ethernet 0/2. And in here, I'm going to say IP OSPF priority. And if we question mark that, we can set a priority between 0 and 255. So if we did not want R3 to be part of the election process, we would set the priority to 0. That will make sure that router 3 is not going to be part of that election process, and it will never be either the designated router or the backup designated router. But for the purpose of this lab, we are going to set the priority value to 200 to make it higher than the other ones. And then I'm going to hit end. And then I'm going to jump into router 4 and I'll do the same thing. And here I'm going to say interface gig ethernet 0/1, and I'm going to say IP OSPF priority 100. And then I will do the same thing for router 2. So router 2 will be a priority value of 20. So now that we've done that, if I were to issue the show IP OSPF interface brief, as you can see, the current router or router 2 still the DR other. And if I were to jump back to router 4 and issue the show IP OSPF interface brief, you can see that this router is still the DR for this network. So in order for us to actually force router 4 to be the BDR, since we set the priority value for each router in the multi-access network, we would need to issue the clear IP OSPF process. You can see that our neighbors have been bounced. And now if I up arrow this again multiple times to get to that command, show IP OSPF interface brief. Now, if we were to look at the output, you can see that this gig ethernet 0/1 network, now the router is the BDR. And if I go back to router 3 and issue the show IP interface, OSPF interface brief, now you can see that router 3 for this network is the designated router. So with that being done, let's jump into the next step where we need to do some in-flight checks. So I'm going to say show IP route. We just want to make sure that all networks have been learned. So we can see the 1.1.1 for router 1 network and 2.2.2 for router 2, a loopback interface, and the same applies for router 3 and router 4 as well. We can see the 10.0.0.0/30 network. This is the link between router 1 and router 2. We also have learned the 192.168.10 network, which is the LAN network that is attached to router 1. And also finally, we can see that this network is part of the LAN network that is attached to router 4. If I were to issue the show IP OSPF database, we can see that we have a new table entry here that is part of the area 0, and this entry indicates the information related to the DR and BDR. Okay, so next I'm gonna try to initiate a ping from PC1 to PC3 and from PC1 to PC4 as well. So I'll go to PC1 and I would say ping 192.168.30.3. And we have reachability to PC3. I'm going to do the same for PC4. And we have reachability and connectivity between all three main networks. So that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.